Hi, so on the board here today I have a interesting problem. We're looking at the trapezoidal rule. So this is going to be video number 4 in the series on Riemann sums. So in the previous 3 we found the right Riemann sum, the left Riemann sum, and the middle Riemann sum. And then this, so technically the trapezoidal rule is not a Riemann sum, it's just closely related. The Riemann sum is when you estimate the area under a curve with rectangles, and here we're estimating the area under this curve with trapezoids. So again, the same as in the other videos, we're using our function f of x equals x squared plus 1 on the interval 0 to 6. Okay, and so here on the graph I've done here, we have our curve of x squared plus 1, and all we want to do is we're doing a rough estimate, right, a very rough estimate of the area under this curve. And so in this video, instead of using, like I said before, instead of using rectangles, we're using trapezoids, so you can't really see it too well in these first two regions, okay, because it's very close to the curve. But in the third region, you can see that our trapezoid is a little different than our actual region under the curve. But you can kind of see that this is going to be a pretty good estimate because we're maybe overestimating a little bit here and a little bit here, but it's not too bad. So this will probably be a pretty good estimate for the area under the curve. So let's get started to find the area of these three trapezoids. We just need the heights of all these points. So we have the height at 0, f of 0, just plugging into this equation, is 0 squared plus 1. So that first height is 1. Okay, let's just go through and get all the heights first. So then at this endpoint, this height, f of 2 is just 2 squared plus 1 equals 5. I'll just write it in there like that. So that's a 5. F of 4 is going to be 4 squared plus 1 equals 17. And this last one at 6, f of 6 is 6 squared plus 1, which is 37. So then, just a quick, when you have a trapezoid, and we'll actually kind of, all of our trapezoids look kind of like this. It's just, if this is A and this is B, then we'll say this is our width, then the area is just going to be A plus B over 2. So like the average of the heights times the width, and that's how we'll find the area of each of these trapezoids. But we have this A and B height, we have these, this is what we just found. So let's go through and calculate each area. So our area of the first piece is going to be 5 plus 1 over 2 times the width of 2. You know what we'll do, we'll calculate at the end, we'll just write down what we've done here. So in this one, it's going to be 5 plus 17, the two heights divided by 2. Width is 2, the width's going to be 2 in each of these. We get a standard width of our intervals or subdivisions. Then this last third region, the height is going to be 17 and 37. So we'll take the average of those two times the height of 2. Then, you know what, let's, to make our calculation, let's just do each of these. So, okay, this is a 3, this is going to be 6 divided by 2 is 3, 22 divided by 2 is 11, 54 divided by 22 is 27. Is that right? Yeah, that's 27. And then so for our final calculation, I think what I'll do is just factor a 2 out just to make it a little easier. So we'll have 2 times 27 plus 11 plus 3, but this number is going to be 41. Yes, so for our, we'll just write in our little table here, so our estimate for the area using a trapezoid is going to be 82.